Welcome to The Explainer. Today, we're unpacking something that is honestly fundamentally shifting how developers and scientists interact with computers. We are talking about the Julia programming language. Now, if you spend any amount of time in the software world, especially if you're wrestling with massive data sets or complex math, you know there's this nagging, persistent headache developers face every single day. It's a massive hurdle. It affects how fast we can build things and, well, how well those things actually run once they're built. So today, we're going to look at exactly how Julia was designed from the ground up to completely obliterate that hurdle. Let's get right into it.
Okay, let's dive into this. The big question: must we choose between speed and simplicity? For decades, this classic programmer's dilemma has forced the whole tech industry to basically operate on a compromise. It was just this accepted reality, right? If you wanted a language that was easy for a human being to read and write, you had to sacrifice raw computational speed. And on the flip side, if you needed absolute blistering performance from your machine, you had to write your instructions in a language that was incredibly complex and, frankly, time-consuming for humans to manage. You constantly had to ask yourself, what's more important for this specific project? How fast my team can build it, or how fast the computer can run it?
To really visualize this tug of war, let's look at two heavyweights in the programming world. On one side, you have the simplicity of languages like Python. It's incredibly user-friendly, it reads almost like plain English, and man, you can prototype an idea so fast. But when it comes to raw execution speed, it can sometimes drag its feet a bit. Now, over on the other side, you've got languages like C++. C++ is basically a race car. It offers blistering speed and gives you total, absolute control over the machine's resources. But writing in C++? Yeah, that requires a high level of expertise. It's complex, and it takes significantly more time to write and debug. Because of this, developers often find themselves trapped in what's known as the two-language problem. They'll write a quick prototype in a simple language just to see if the idea works, and then they have to completely rewrite the entire thing in a fast language like C++ so it can actually handle real-world demands. It's exhausting.
Enter Julia. The entire reason this language was created was to break this exact frustrating cycle. Its core goal is beautifully simple, but absolutely ambitious: to combine the simplicity of languages like Python with the speed of languages like C++. Just take a second to really appreciate what that means. You no longer have to prototype in one language and produce in another. No way. Julia allows developers to write fast, highly efficient programs using only one single language. It completely bridges that huge gap between human ease of use and machine high performance, a real game changer.
So where exactly is this one-language powerhouse actually being deployed? Well, Julia is a modern programming language specifically designed for the absolute heavy lifters of the tech world. We are talking about scientific computing, massive-scale data analysis, complex statistics, and, of course, the incredibly fast-growing field of artificial intelligence. What makes this so exciting, though, is its sheer versatility. Because it combines that ease of use with really high performance, it's highly useful whether you're someone who's just learning the ropes of programming or a whole team deploying cutting-edge professional applications in the real world.
And the foundation of this ease of use starts right here, the syntax. Syntax is basically the grammar of a programming language, right? Well, Julia boasts a syntax that is exceptionally clear, simple, and incredibly easy to read. And this isn't just some aesthetic choice to make it look pretty. It's a practical, major advantage. When the code is readable, it directly helps programmers write their initial code much, much faster. But perhaps even more importantly, it makes it vastly easier to understand and maintain that code months or even years down the line. Whether you're reviewing your own work or collaborating with a massive team, you aren't wasting precious time trying to decipher what the code says. You immediately understand what the code does.
Now, you might be wondering, how does Julia actually achieve its incredible speed, despite being so easy to read? Well, the secret lies in something called just-in-time, or JIT compilation. Think of this like a brilliant, lightning-fast live translator. Instead of translating the entire program into machine code before it even starts, which, takes a lot of time, or interpreting it line by line incredibly slowly, Julia's JIT compiler actually creates optimized machine code while the program is running. It actively analyzes what the program is trying to do at that exact moment and optimizes the translation on the fly. This makes the overall execution significantly faster.
But Julia isn't just fast. It's also incredibly flexible and packed with built-in power right out of the box. Look at the programming styles it supports here. You aren't boxed into just one way of thinking. Julia seamlessly supports procedural, functional, and object-oriented programming styles, so you can approach a problem whichever way makes the most sense to you. And then there's the math. For scientific applications, you absolutely need heavy-duty math capabilities.
Julia includes built-in tools for numerical calculations, complex matrix operations, and linear algebra. And why does this matter? Because it dramatically reduces your dependence on external libraries. You don't have to go hunting around for third-party add-ons just to do basic science. The tools you need are already woven directly into the very fabric of the language itself. Which brings us to the absolute crown jewel of Julia's architecture, multiple dispatch. If JIT compilation is the engine, multiple dispatch is the highly advanced navigation system. In simple terms, multiple dispatch means that Julia automatically selects the absolute best, most optimized version of a function based on the specific types of data you feed into it. This is a massive advantage. It means your programs become incredibly flexible, automatically adapting to the data they're processing while remaining fiercely efficient right there behind the scenes.
To see exactly how multiple dispatch works in practice, let's look at a little mini-story involving a function we'll call calcular. Imagine this function has two totally different versions, or behaviors, programmed into it. If you feed calcular whole numbers, what programmers call ints, Julia instantly recognizes that data type and automatically routes it to perform addition, giving you the sum. But if you feed that exact same calcular function decimal numbers, known as float64, Julia instantly adapts. It recognizes the decimals, automatically routes them to a totally different version of the function that performs multiplication and gives you the product. It's like Julia acts as the ultimate matchmaker, automatically choosing the correct version of the function without you needing to write clunky, complicated if-then statements. And remember, all of this is happening while using that JIT compilation to make it lightning fast and utilizing built-in math tools without needing extra libraries. It's pretty amazing.
So the crucial point to take away from all this is you get the whole shebang. You get the easy-to-read syntax, you get the incredible flexibility of multiple dispatch, you get the built-in mathematical power. And yet, because of that brilliant JIT compiler optimizing code during execution, you still get high performance. We're talking about execution speeds that match the raw, heavy-duty power of languages like C and C++. Julia absolutely delivers on the promise of giving you your cake and letting you eat it too.
Which leads us to a rather profound question to wrap up this explainer. We've seen how Julia basically shatters the old compromise, offering the ease of Python and the power of C++ in one single, incredibly smart package. So, if one language can finally do it all, if you no longer have to maintain prototypes in one language and production systems in another, is it time to rethink how you build your projects? Is it actually time to rewrite your code? It's a fascinating thought, isn't it? I hope this deep dive into Julia has given you exactly what you need to start exploring that answer for yourself. Thanks for joining us on this explainer, and we'll see you next time.